So this is the Prelab help video for Lab 4. Specifically, it's about how to calculate the uncertainty on a final value when you're calculating it from several measured values that also have uncertainties. So before I begin with that, I'm just going to talk a little bit about how you calculate an absolute uncertainty when you've been given a percent uncertainty. So for example, say you've been given 1% as the uncertainty on a photo gate time. And maybe when you're writing things down in your table, it specifically asks for both the percent uncertainty and also what's called the absolute uncertainty, which would be just a number. So how do you get that? Here's your value, and you basically want to calculate 1% of that value. The way you would do it, if it's 1% specifically, is you just multiply by 0.01. So you take your final value, 5.7, multiply by 0.01. That gives you 1% of 5.7. And that is your absolute uncertainty. So that's what I've written down here, is it's 5.7 plus or minus 0.057. And both of these values have the same units, so if this was a time, for example, the units would be seconds, and you just write seconds at the end of it. And now I'll go on and talk a little bit about the rules for how you calculate the uncertainty on a final value from measured values that had uncertainties. So say, for example, you've measured a distance, and you've measured a time, and you need to calculate the velocity. You can do that directly, but if d and t both had uncertainties, then v also must have uncertainties, and that's something you need to calculate. So the rule for multiplication and division is always the same. It's that you're going to add up the percent uncertainties. So it doesn't matter whether you're dividing or multiplying. In both cases, you still add the percent uncertainties. So if d has a percent uncertainty of percent d, and t has an uncertainty of percent t, you just add those up, and that's the percent uncertainty on v. So same thing, if you're multiplying, you just add up the percent uncertainties, and that gives you the percent uncertainty in your final answer. So now we'll go on to how you calculate the final uncertainty when one of the quantities that you're calculating with is squared or cubed or raised to some other power. So the rule is simply that if you've got t squared in your calculation, then when you add up the uncertainties, you're just going to say 2 times percent uncertainty of t. So whatever the quantity is raised to the power of, that ends up being something that's multiplied by its percent uncertainty. So in this example, we've got 1/2 times a times t squared. So using the multiplication division rule, it would just be the percent uncertainty of 1/2 plus the percent uncertainty of a plus 2 times the percent uncertainty of t. 1/2 is a constant. That means it's an exact value. It has 0 uncertainty. So its percent uncertainty is actually 0. It drops out of the equation. All we're left with is percent uncertainty of a plus 2 times the percent uncertainty of t. Now the logic for why whatever this is raised to the power of winds up here is actually pretty easy to understand. If you look at this, we've got 1/2 a t squared. That's just equal to 1/2 times a times t times t. So then when we actually work it out using the multiplication division rule, the percent uncertainty of t happens twice. So they just brought them together and said 2 times percent uncertainty of t. What's neat about this rule, however, is that you can use it to apply to things where that's not necessarily intuitively clear that that's how it works. For example, say you've got some quantity and it's all square rooted. You can still apply this rule, except you have to remember that a square root is like raising something to the power of 1/2. So when you use the multiplication division rule and you sum up all the percent uncertainties, you just add a factor of 1/2 to everything that is raised to the power of 1/2. And of course, g and 2 are constants. They're exact values, so their percent uncertainty is 0. These two terms drop out of the expression, and what we have at the end is just 1/2 times percent uncertainty of d is the percent uncertainty on t. And finally, there's one last question, which is just sort of a housekeeping question, that is, what do you do when you have to add or subtract? How do you get the percent uncertainty on the final answer? So say we've got 2 objects and we weigh them both, so we know the mass of them, and we've got the uncertainties on the masses, and we want to add them together to get a total mass and also find the uncertainty on that. What do? The short answer is that there's a way to do it, but you can't do it with percent uncertainties. So in this course, we just skip it. We try and avoid doing that. When you go on to another course, like Physics 1101 or 1120, you'll be taught how to find the uncertainty in the final answer when you're adding or subtracting. In this course, what we usually do is you would take these two objects that you're weighing, you'd stack them together, and you'd just weigh them together. And then you'd know directly the uncertainty on the total mass because you'd get that off of the scale. We actually do this in labs 6 and 7.